What happens when Earth can no longer carry us? With the rising seas, dwindling resources, hostile climates, humanity, it's always looked to the stars as an escape hatch. Among thousands of exoplanets discovered, one has stolen headlines and imaginations alike: Kepler-442b. So, will Kepler-442b remain a distant dream? Or will it one day be our second home? Kepler-442b orbits a small orange dwarf star, about 1,200 light-years away, in the constellation Lyra. Discovered in 2015 by NASA's Kepler Space Telescope, it immediately stood out. Kepler identified it using the transit method, watching for tiny dips in starlight as the planet crossed its star. This allowed astronomers to calculate its size, orbit, and position in the habitable zone. Why? Mainly because it is one of the most Earth-like planets we've ever found. At 1.34 times Earth's size, with a rocky surface and a location in its star's habitable zone, Kepler-442b ticks nearly every box for habitability. The star it orbits, Kepler-442, is cooler and dimmer than our Sun, but this actually works in the planet's favor. It means less damaging radiation and a longer stellar lifespan, giving potential life more time to evolve. And yet, size and orbit alone don't make a world livable. To see why Kepler-442b matters, we must examine what sets it apart from the thousands of other exoplanets we've found. Most exoplanets discovered so far fall into three frustrating categories: too hot, too cold, or too massive to be rocky. Kepler-442b, it's different. It sits in the Goldilocks zone, where liquid water could exist on its surface. Even more promising, its star is remarkably stable compared to flare-prone red dwarfs like Proxima Centauri. This stability matters. A planet bathed in violent stellar flares, it would struggle to hold onto its atmosphere, sterilizing its surface. So, Kepler-442b's calmer environment makes it a far better candidate for sustaining a biosphere. Still, there are uncertainties. Its radius is well measured, but its mass is only estimated, likely 2 to 3 times Earth's. That suggests a rocky world, though we don't yet know its exact density. Despite this, it consistently ranks among the highest on the Earth Similarity Index, with a score around 0.84. But stability and orbit don't guarantee habitability. To truly matter, Kepler-442b must answer a critical question: does it really have an atmosphere? A planet's atmosphere is its shield, its regulator, its breath of life. Without one, even the most perfectly placed world becomes a lifeless rock. For Kepler-442b, the atmosphere is the great unknown. Until telescopes reveal more, its climate remains pure educated speculation. Scientists suspect Kepler-442b could support an atmosphere thick enough to trap heat, much like Earth's. If it does, the surface temperature might be similar to ours. Without it, the planet could be frozen or scorched depending on conditions. Right now, we don't have direct atmospheric data, but missions like the James Webb Space Telescope, JWST, are sharpening their gaze. JWST is capable of analyzing the light from a star as it filters through a planet's atmosphere, searching for chemical fingerprints, oxygen, methane, carbon dioxide, water vapor. All of these hint at climate conditions or even biological activity. If Kepler-442b passes this test, some argue it won't just be potentially habitable, it could become the top candidate for the first true Earth 2.0. And that leads to the natural question: what would it actually feel like to live there? The first step onto Kepler-442b would feel strangely familiar. Gravity presses only a little harder than Earth's, just enough to notice. Overhead, the star burns orange under the glow of a cooler, steadier star than our Sun. Days, they stretch longer here, while the years slip by faster, just 112 Earth days for a full orbit. Seasons would still turn, marking time on a world that might echo our own. If its atmosphere balances just right, temperatures could be comfortable. Too thin, and it freezes. Too thick, and it swelters. And within that fragile balance hides the most thrilling possibility: Kepler-442b may already be alive. If Kepler-442b truly has water, a stable climate, and billions of years of stellar stability, then life may already have taken hold. Microbes, plants, or even complex ecosystems could exist under its orange skies. Some astrobiologists, they even argue it may be more habitable than Earth. Our planet, it's endured many mass extinctions, from asteroid strikes, volcanic supereruptions, and solar variability. Kepler-442b's calmer, long-lived star could give life an easier evolutionary path. And if that is really true, the question shifts. It's no longer just can we live there, but also who or what might already call it home. Of course, dreaming of alien forests and oceans, that's easy. Reaching them, that's another matter entirely. And right there lies the brutal catch: 1,200 light-years away. Even our fastest spacecraft like Voyager or New Horizons would take tens of millions of years to arrive. For Kepler-442b to truly be our future Earth, we'd need propulsion breakthroughs, warp drives, wormholes, or generational starships. Concepts like nuclear fusion rockets or antimatter engines exist in theory, but nothing close to reality. This makes Kepler-442b both tantalizing and frustrating, the perfect candidate for colonization, locked behind an insurmountable wall of distance, and yet studying it still matters deeply. If we can't get there, then why should we bother? Because studying Kepler-442b reshapes how we see ourselves. It proves Earth is not unique, that habitable conditions can form in many corners of the galaxy, and that humanity's survival isn't chained to this one fragile blue dot. Every discovery, like Kepler-442b, expands our knowledge of planetary formation, atmospheric chemistry, and the conditions needed for life, and in doing so, it holds up a mirror to our own future. Kepler-442b isn't just another planet on a chart, it's a glimpse of what endurance looks like. Orbiting a star that could shine for tens of billions of years, it may enjoy far more stability than Earth ever will. Meanwhile, our own sun is already halfway through its lifespan, reminding us that habitability has an expiration date. That contrast cuts deep. If another world could hold life for eons, why do we struggle to safeguard ours even now? Rising seas and vanishing ecosystems show how fragile our balance is. Kepler-442b, it doesn't only inspire hope, it challenges us to prove we can preserve the gift we already have. Still, hope often sparks ambition. Kepler-442b has become a blank canvas for humanity's most daring visions. Some imagine titanic starships, floating cities where generations are born and buried before their descendants finally reach alien soil. Others picture AI fleets sent ahead of us, building shelters, shaping climates, and carrying the blueprints of life to be reborn under an orange sky. Each vision reflects the same truth. We see Kepler-442b not just as a refuge, but as the setting for humanity's next great chapter. If Kepler-442b is close but not quite ready for us, could we reshape it? With stronger gravity than Earth, it might retain thick atmospheres for eons, making climate engineering more feasible. Ideas range from releasing greenhouse gases to redirecting comets for water delivery, even sending microbes that exhale oxygen into the air. The irony is sharp. We're already altering Earth's climate unintentionally. If we ever learn to wield that power with precision, the same knowledge could transform a distant planet into a true second Earth. But there's a deeper riddle. If planets like Kepler-442b exist, rocky and well-placed for life, why does the galaxy remain silent? Perhaps most biospheres never get past microbes. Perhaps civilizations bloom but collapse before they can spread. The great filter, Kepler-442b, could be vibrant and thriving, yet empty of minds. Or it could hold ruins, the echoes of a species that rose, advanced, and vanished. If so, its silence is not emptiness, it's a warning. For now, only telescopes can bring Kepler-442b closer. The James Webb Space Telescope, it's already scanning for atmospheric clues, and the upcoming Habitable Worlds Observatory will sharpen that search, hunting for traces of water, oxygen, or methane. Meanwhile, concepts like Breakthrough Starshot hint at future probes that might one day cross interstellar space. Though Kepler-442b remains far beyond reach. And yet, even at distance, the planet matters. It proves Earth is not unique, that across the galaxy, other worlds may cradle life, or its remnants. So, is Kepler-442b our future Earth? Maybe. It's the closest candidate we know so far, a rocky planet in the habitable zone of a stable star. It might hold oceans, clouds, even life. Yet, its distance keeps it out of reach. For now, Kepler-442b is less a destination than a beacon, a proof that habitable worlds exist and survival beyond Earth is possible. But it also warns us, before we dream of living elsewhere, we must protect the home we already have. Kepler-442b, it's not just a planet, it's a possibility, a reminder the universe offers other homes. And if this journey fascinated you, be sure to like, subscribe, and hit the bell so you don't miss the next exploration of our universe.